welcome to another mathematical experience, if you will. We're going to look at LU factorization. This is a process that you do a lot of times with linear algebra. We are going to be looking at how we can transpose this matrix right here, matrix A, into matrix L, and what is going to become matrix U. Right now I have this as labeled as A2, and we'll get to that and how this will become matrix U. The idea behind this is just to give us another way to solve a system of equations, if you will, another way to deal with solving a matrix in such a way that is a little bit easier sometimes than using row-reduced echelon form or other methods that we have of doing that. This just gives us another tool in our bag here to work with things. So the first thing we're going to do is we're going to take our matrix A, and we're going to look to see how can we get this in echelon form. Now, echelon form just simply means you have a diagonal of numbers, and you're going to try to get zeros below the numbers. We really don't care what's above it. It can be numbers, it can be zeros, with zero is a number, right? But what we want is these three positions on this one. Since this is a 3 by 3, we want that to be, we want those to be zeros. We're going to simultaneously, while we do that, we're going to be creating our matrix L, and I have L1, L2, and then the final L as well here. And the first thing I can do is I can go to A, I can divide this entire column by the value that's going to turn that first position, which is our pivot position. This piece right here, that 2 is our pivot positions. All the values in our diagonal are pivots. And our first pivot is going to be 2. 2 divided by 2 gives me 1, which means I'm going to divide everything else in that column by that value of 2. So 2 divided by 2, 4 divided by 2, 10 divided by 2, which gives me 1, 2, and 5. So there's our first matrix, and then everything else I'm just going to kind of leave these little dots right there as placeholders until we get to the next iteration here. But we need to do a calculation over here first. So what I'm going to do is I'm going to say, I need to rewrite row 2. Well, how do I need to rewrite that? I need to rewrite it so that this 4 right here becomes a 0. So row 2 is going to become row 2 plus negative 2 times row 1. And I'm going to simultaneously do the same thing to row 3. So row 3 is going to become row 3 plus negative 5 times row 1. You can do this in lots of different ways. You can divide through by a number. You can do all sorts of things with this. I find this to be the most efficient way of doing this. It doesn't necessarily give you always the cleanest numbers, but to me it seems like the simplest way because we're not having to mess around with what this value is or what that value is or keep track of lots of fractions. But when I do that, I do those calculations and I end up getting 0, 2, and negative 2, and then I get 0, negative 8, and negative 6 as my values when I do that. Now, if you want to understand where did I get 2 from, I'll run through the first process, and then you can kind of pause the video as you need to verify the other values. But what I did is I took negative 2 times row 1, so it's negative 2 times negative 2, and I added it to row 2. So this position times 2 plus 4 gives us 0. 1 times negative 2 plus 4 gives us 2. Negative 2 times 2 gives us 4 plus, negative 4 plus 2 gives us negative 2 as the result. So you do that same process with the next one. Just go through it, multiply negative 5 by everything in that first row, and then add it to the third row. That gives you the new third row. Now at this point, we're going to pause with doing echelon form for a second, and we're going to notice that now in our next pivot position of 2, this is what we're going to be using over here. We need to take this pivot right here, and we need to make it a 1. 2 divided by 2 gives us 1. We need to divide everything else below that by that number, which in this case gives us negative 4. We're not going to worry about above that, because the underlying idea behind L2 is that we have a diagonal of 1s in our pivot positions. 1, 1, and 1, so this next position down here is going to be a 1 as well. We want 1s right there, and that's going to give us our L matrix. So now we come back over to this one, and we're going to say, well, you know what? We almost have that diagonal of numbers there, and we almost have this value right here as being 0, or the numbers below, rather, that little triangle there. So the thing I need to do next is I need to do R3. That's going to be equal to R3 plus 4 are 2's. 2 times 4 is 8. 8 plus negative 8 gives us 0. So then we can just start filling in, right? And then we can end up with a negative, what do we get? Negative 14 here. So now, we go back over here to L. We can fill in, we got 2 and 1, 5 and negative 4. And then there's that 1 that was already kind of there. Because the next thing we would do is say negative 14 divided by negative 14, which gives us 1. And everything else, the diagonal or the triangle above that diagonal of 1s is now 0. So now this thing, that's U. And this is L. And you can verify that this actually worked by going back and doing A is going to have to be equal to L times U. But it's not necessarily true the other direction. Okay, so if you're multiplying this out, be careful, because if you do L times, or U times L, right, this is not necessarily true. Okay? It might be, but multiplication of matrices is not necessarily commutative, so we can't necessarily switch the order in which we're doing them. L times U should give you A. All right? It doesn't mean that U times L is going to give us A, but L times U should give us A every single time. Because what we did is we actually found a way to decompose A into 2 other matrices. And then we can use these matrices that we just created, L and U, we can use them to do other processes with. Namely, what we're going to do is we're going to use them to solve systems. So I may have a vector matrix that is a list of answers, if you will. And normally what we would do is we might augment this matrix with that vector. And then we could solve that vector by putting it in row reduced echelon form. Well, this is another process now that we have L and U, where we can now go back through and we can figure out what that other value is, or what those values are for this process. All right? There's another video that will come along with this to show you what you do with these values of L and U. All right? Take care.